Hello everyone. For my Raspberry Pi project, I built a simple but functional private cloud storage server using the Nextcloud web. It allows me to upload and download file through the web and just like a Google Drive, but fully hosted on my own Raspberry Pi. So I chose this project because I wanted more control over my data, and it's a great way to learn about REST storage and web server and Linux system administration at once.
So this project shows how Raspberry Pi hardware works together with the software. So first, the ARM CPU and the RAM here handles multiple tasks like managing the RAID array and running the web server at the same time. And second, I created RAID 1 setup using these two USB SSDs with the Amendem tool and showing how Pi supports the reliable storage. And third, the USB 3.0 port is also here. Connects the drives and allow fast data access. And fourth, I connect to the campus Wi-Fi which allows me to run full TCP and IP stack to serve the files over the HTTP. And here is my keyboard and mouse port, and here is the HDMI port, which I can display it on my monitor. Finally, the OS run the Debian based OS runs the Madam for the RAID, and a patch with PHP provides a working web interface. And about the software, I will talk about later. So now I will show you the general procedures I've done during my work. Because it's a demonstration, so some of the code I will not actually run it. So first, I will refresh the package list and install all the available updates here, and then I will install the Amdam for the RAID management, and patch 2 for the web server, and Mary Adab for the server for the database support, and also the PHP for the server-side scripting. And then I will check use the LSBOK for listing all the block devices, and so that I can identify which are my SSD. So I named the SSD A and the SSD B. So here's the two SSD, and then I will create a RAID arrow. It is here. So this one should be first, and then after I create them, can use this to check the status of them. To show here, there's 2 of 2. That means both of the SSDs are working and already psyched. And then I will use the Nano to open the PHP script in text editor. So here I can add the code to handle the file uploads and the list uploaded files. And then I will send the header only request to the upload page to verify it returns it usually returns the 200OK, which means the website is actually working well. And then I will use the ngrok to expose the web to the public URL. So here it says online, and it's working well. So yeah, that's the procedures.
Hi everyone. So here is the demonstration of my final project. So I created a website with the Pi, and I built a RED with this website to make it uh, open for everyone. So once we type in my Pi's local IP, it is here 1006943 and 55. And here is the website I use. So when we come into the website I built is powered by the Nextcloud. It's a free and open source self-hosted cloud storage platform, and it is deployed on my Pi using the Red One setup and to ensure the data redundancy and safety. So uh, the users can log in to to ensure the safety of the documents. Here I already logged in, and also here users can upload anything, files, photos, or documents, or whatever they want. And as long as my Pi is turned on, is opened, everyone can access to this website using my local using my local IP. And for example, if I wanna upload the file here, uh, let's say we upload this photo, and it will come to here, and you can view the photo uh, online, and you can also download it to your local device. Here, here it is. So um, So yeah, I think that is almost everything I have on this website. It is very quick and easy to use. Um, yeah, so I think yeah, that's it. Thank you. So here about troubleshooting, I encountered three main problems during the project. First is the 403 forbidden arrow. Uh, when I try to access the website, I got this error, and this happens because the red mount dictionary, SRV, uh, was not owned by the root, and the patch didn't have the permission to read or write file there. To fix it, I ran this and this to code to after and then after restarting the Apache, the site loaded successfully. And second is the initial recite process was extremely slow, and it was taking me very long time to finish it, which made the testing harder. So I solved this by enabling an internal bitmap using the command uh, sudo mandem. This code. This makes the recite much faster and more efficient in the future reviews. And the third one is I had a serious issue where the file system suddenly become read only. This was caused by the improper shutdown that corrupt the read volume. I first stopped the patch and the MariamDB, and then unmounted the RAD this with the sudo unmount and ran a file system check using the sudo fsck.ext4, and after that I used the sudo man um, then assemble force the menu reassemble the arrow, and finally I remounted it and restarted the service, and this fixed the problem and restored the server to a normal operation. And about my lessons I learned through this project. I learned how to set up and manage the red arrow on Raspberry Pi using MDEM, and how to recover from file system error using FSCK. And I also configured Apache and PHP to support file uploads and optimize the server using the Wi-Fi, and this helped me better understand Linux system management and service configuration and networking. In the future, I plan to automate everything using a symbol and add a UPS to prevent data loss during power outage, and this improvement will make the system more reliable and easier to maintain. Uh, that's it. Thank you for listening.